And I'll keep the Discord up as well.
Oh yeah, that's a good idea.
And we are live. So welcome everyone to Deno Sessions. This is me, Andy from Product Marketing, and Bartek couldn't join today, but our special guest, our highly secret special guest, is Leo. You may all know Leo from our Discord. He's one of our software engineers, works on the CLI. And today we'll be just talking about most recent updates, and Leo will do continue some of the work that Bartek was doing in terms of embedded JavaScript runtimes. Leo, how are you?
I'm doing well. You?
Good. How's your week so far? It's Wednesday. How's your week been?
I mean, so far it's been pretty decent.
That's good.
Nothing too amazing happening, just the usual.
Just the usual. What time is it over there right now?
Oh, good question. It's 7 p.m.
Oh, okay. Yeah, it's still light out. Looks nice.
Yeah. A few weeks ago, it would still instantly be dark by now. So
yeah.
It seems changing quickly the time.
Spring has sprung.
Yeah. What time is it over there?
It is 10 a.m. So it's
okay.
Morning. Yeah. So if you're watching right now, I will be keeping an eye on the chat on YouTube and also the chat in Discord. So if you have any questions, just feel free to drop them in there. And I'll bring it up. But first, before we get started, let's just talk about the most recent release, which is 1.32, and I'll pull up the blog post and we can talk about it. 1 second, gotta find it first. Here we go, and I'm going to share my screen. Awesome. And I need to make this. Boom. Great. Let's talk about this. This release came out a few weeks ago. And what were some of the big updates on this? I know the big thing really was the enhanced Node.js compatibility. Anything else that you think is worth calling out here?
I mean, there is the TypeScript 5.0 release that's included in this release, which is a huge thing.
Yes, TypeScript 5.0 and also V8 11.2.
Yeah.
Big update with TypeScript. ES decorators are not yet supported. We're working towards that. This is big. Obviously, you always want to try to stay in lockstep with the newest TypeScript. So,
I heard it was quite ordeal to get this working. So it's great that we managed.
Oh yeah. What were some of the challenges?
I'm not too sure. I believe that the new TypeScript release had some internal APIs changed and removed. So it made it a bit more convoluted for us to include it in our system.
Yeah, always changing those internal things, Why can't it always be as simple as just changing the number from 4 whatever to 5? But yeah,
exactly.
TypeScript. This is a big deal. I'm looking at the performance improvements. This is definitely. Always trying to shave off milliseconds here. So I think this is a big impressive undertaking. 2x speed ups in type checking, which is huge.
Oh yeah, definitely. I mean, type checking has always been slow, so its speeding up is very welcome.
Yeah. And just thinking about TypeScript and Deno going forward, we've always tried to make TypeScript be such a seamless part of the Deno experience, and first removing type checking from Deno run, and then now doing this. If anyone's watching and they're using TypeScript and they have any feedback with Deno and TypeScript, please leave a comment. Like, we'd love to. That's really important to us, so we love to read that and help make it better for you. Let's see. Anything else with the Deno 1.3.2? I mean, the big thing really that big update, in the past week and a half is Ryan's talk at Node Congress.
Yeah.
Did you see that?
I watched bits and pieces of it.
Yeah. The big thing really is the KV, and I know everyone's at least from what I read on Twitter, everyone's very excited about it. And yeah, we quietly pushed that out in the release. It's behind an unstable flag.
Yeah.
And if you haven't seen the demo, go to our YouTube. If you go to our YouTube, we have a video of Ryan giving the talk at Node Congress, and he gives a demo for Deno KV, and it looks pretty good. Yeah, Leo, what do you think?
Yeah, I've been messing around with KV as well. It's definitely great.
Yeah, super easy. API is super simple, and I think what's great is that they do atomic transactions. So
yeah,
for a distributed database, that's something that I haven't seen really. So I'm very curious to see the kinds of apps that people will build using that API.
Yeah, I mean, definitely gonna switch over some of my projects to use it. It's gonna make it just
definitely
a lot more streamlined. Everything be in its place together. Don't have to worry about one thing being over here, using another project like AWS or Google Cloud. Just everything is together.
Yep.
On Deno.
Yep. And I think that's going to be it really is the vision of Deno, which is trying to make programming as easy as possible. So
yeah,
with minimal config, without having to go to a separate database to grab secret API keys and things like that. And yeah, having everything in one location, I think is nice.
Yes.
Cool. Let me stop sharing this and let me just look at our chat. Nope, no chats yet. Well, why don't we just get started then? Yeah.
Sure.
I will add your thing to the stream. Okay, great. Awesome.
Right.
So just some context, if you're joining us now and you missed the last 2 live streams where Bartek and I were basically building upon his blog post, Roll Your Own JavaScript Runtime. I'll drop a link to that in the comment section so you can take a look for reference. But yeah, Leo, why don't you chat a little bit about what we plan to go over today?
Yeah, so today we're gonna mainly focus over a few questions that were posted in the issues on our repo, and that's mainly going about snapshotting. So snapshotting is basically taking the state that the JavaScript runtime is in that moment and storing it, and then later on being able to recall whatever that state is, which makes it fairly more easy to have let's say a build step ahead of time that you then snapshot, and then you can always call up later. And snapshotting is also great because it also improves performance on the cost of increased file size, but it's a negligible amount of file size, so it's actually a reasonable thing to do.
Yeah, so why wouldn't everyone just use snapshots all the time? It seems like a cheat code.
Snapshots are I mean, when we were building the snapshot stuff in Deno a few weeks ago, the problem was it's not too well documented, maybe, and there's not that many people that know much about it. So we were struggling a bit because we did not know what we were doing some of the times, because no one really knows how it works. So, but I think we have gotten the knack of it. We've understood how few things work. And yeah, I mean, I think Node is also going on the topic of using snapshots, or already is, if I don't remember correctly. So yeah, it's definitely more people are starting to use it after that we show that it does improvements to the runtime and performance, and that it's just a nice way to set things up.
Awesome. That's great. Yeah, let's get started. Do you mind bumping up the text size?
Sure.
I'm an old person, and you just see my phone. My phone is like the largest font because I just don't want to use my eyes. That's perfect. Yeah, great.
Okay, good. Yeah, so let me see. We had a few questions. Okay, so wait, do you want me to pull it up on the screen, the questions that we had?
Sure. Yeah, is this from the GitHub issues?
Yeah, it's on the Deno repo actually, but let me see.
Oh, interesting. Snapshotting. Where is snapshotting?
Here we go. So, yeah, so there's mainly questions regarding how Deno itself does the setup of snapshots, and a few questions surrounding all of that involvement. But I think we're going to answer those a bit later, those more specific ones to Deno, and use this more of a base to implement the snapshotting logic in the runtime example that Bartek worked on the previous weeks.
Great.
So let me see. Let me just quickly skim through what they were asking. Okay, so most of these questions are really about Deno itself, how the setup is. But yeah, some of these questions are good for now as well. I will cover this question in a second. So let's see, let's get started with actual work. Let me remember. How does this work again? Yeah, so we evaluate. Okay, yeah, so we have all of these things that Bartek defined, like these random set of APIs like fetch and reading and writing and deleting files and a timeout. So what we're gonna do, I think, is we're gonna snapshot this file pretty much, or whatever the engine is, the state of the engine is after this file, and then load up the snapshot again at runtime. So we don't have to generate or load all of this every time.
Awesome.
So it's only loaded once when being built. So for that, we do need to add a build script in Rust, I believe. So let's add a build.rs. Let's add it to Git. And why? Sometimes I question Rust. Like,
yeah,
this could be auto-discovered. So, wait, what? Did we do anything special here? No. Maybe it's just my ID. My ID likes to mess with me. So I'm just going to ignore it for now. Yeah, so we want to have, obviously, Deno core as a build dependency, because in the build script, we're going to use the APIs provided by Deno core, which is the snapshotting utilities that we have integrated not too long ago. And those provide us with various APIs that we can quickly take a look. Snapshot utils. So this includes a simple utility function that lets us create a snapshot, which just takes a few options. We abstract it as much as possible. So it really is just as simple as it can get. And what we pass to it is this structure, the struct that takes a few options. The two most important ones are the snapshot path. So basically, we have to write a snapshot when we build it to disk. And then when we load it, we need to read it from disk. So we have to specify the path for that, and we have to specify the cargo manifest directory, which is the directory that cargo or the Rust is going to be using as the, let's say, the directory that it's going to be compiling into everything for that specific dependency. And we need to pass that so it knows where to find then the snapshot path, because we want it to be part of the executable and in a place that it's easily be found and consistently be found in a specific place, because we don't want it to be written at somewhere randomly, because then we're going to struggle. Where do we find the stuff? So yeah. The other options are a startup snapshot. So if we want to do snapshot from snapshots, which is also a thing, so you basically have initial piece of code, which in the example of Deno is the Deno runtime crate. That's a snapshot. And then in the CLI, we have another snapshot which we create, which is using this startup snapshot for which we pass the Deno runtime snapshot. So basically, we take a snapshot and add more things to it and snapshot that again.
So can you change snapshots?
Yeah, pretty much.
Interesting. Okay.
Before we had this capability, what we did was, because we have some additional APIs in the CLI, which in the CLI folder, which is, for example, the testing infrastructure and benchmarking, because we don't want them to be part of the Deno runtime crate, because it doesn't make too much sense. Before that, we actually had them implemented in the Deno runtime crate, but we didn't have any of the underlying Rust ops implemented there. So we had to pass them manually from the CLI as a dependency of the Deno runtime crate. It was a bit of a weird setup, but now it's separated. It's much more concise in where it is. So we don't have multiple places where the same things are happening that usually are in a place together. So it's just a much more simpler setup to have everything in its own space, but still be able to connect and work together by appending things to a snapshot. Appending is not exactly the right word. Basically, you load the snapshot up, you open the state up, so basically you load everything that was in the snapshot and then snapshot it again. So it's basically, let's say you're moving and you have a box. The first time you snapshot, you put everything in a box, and then you want to snapshot it again. You basically open up the box and put more things in it, and then close the box again. That's a snapshot from a snapshot. And let's see, compression callback. That's not necessary. It's a callback that's being used on the underlying snapshot, which is to, initialize a compression, which we use in the CLI, as it does reduce file size, but we try to obviously make it not a performance problem. So we use, I think, LZZZ or whatever it's called. I think some weird compression name for that. But in our example, we're not going to bother with compression. It's not mandatory, as it's an option. And the snapshot module load callback is module loader callback. So as Bartek implemented a module loader here for TypeScript, basically what we do in the CLI, for example, is we have a TypeScript module loader, and we pass that for this snapshot module load callback. So we do the TypeScript transpilation of our internals at snapshot time. So we don't load always TypeScript up for whenever we have to run the CLI. It's done once as a build step. Then we have additional extensions. That's if we have to define some extensions. Like that's yeah. Let me remember quickly. Yes, it's for extensions that are getting added on top of the snapshot. We will see an example of that in a moment.
Okay.
So, oh God, let's see if we can make this in time. Do we have any questions yet?
Nope, I don't see anything yet. So, yep. Feel free to continue.
Right. Let's see. Just be quick. Let me just skim through what was done here. So yes, pretty much most of this is gonna get moved to the build script because, well, we want to snapshot all of this together. So especially this runtime.js file, which is the underlying JavaScript implementation of the APIs that were added for this project. So why is this still not recognized anyway? We are gonna, okay. Wait, I quickly have to figure this out. Why is it not recognizing the build script? That is a problem. Let me quickly look at. I guess it doesn't like me.
Is your IDE doing this?
Yeah, I mean, let's try to move it to the root of the project. Maybe that's reload project. Let's see. Yeah, also sometimes my IDE likes to not be too cooperative with anything. Okay, there we go. So I guess that was it. All right. Oh yeah. So yeah, we have the Deno core snapshot utils, which is the main star of the show for this episode. And so we're gonna use this CreateSnapshot API that I mentioned earlier, which will not, okay, it doesn't have a return type, no. So basically just takes the options and does some magic behind the scenes. So let's start with the options and let's set all the fields. So for this cargo manifest there, you always basically just want to add the env cargo manifest there. The problem, we wanted to do this like internally behind the scenes, but it's not possible because it then takes the manifest there of the dependency itself instead of the created reporting. It's a bit annoying, but it will do. This is the path for the snapshot. We can decide at the moment. We don't have a startup snapshot. We're not doing a compression. We are going to have the load callback, I believe, for the TypeScript stuff, though. We can see that in a moment, though. Let's see. Let's see. So, yes, the extension. So we're just going to copy over that extension that Bartek did in the run.js function and just put it in the build script. And we're going to also import any further things that we need. Okay. But, oh wait, let me, oh god, this has been a few weeks. Let me quickly check. Build. What do we do this again? Okay, I think I get the gist of it. Okay, so we're not going to have any of the ops because the ops are in the end just Rust functions that are being called later. So we will include them later on because in the snapshot, we're only going to store the JavaScript. We cannot store like Rust functions like ops. So we're just going to have a small extension that is just the JavaScript files. And this is in source runtime. That should work. Yes, okay. Yeah, so we have the small extension and we're just gonna pass it to the extensions vector, which will just, load all the extensions passed to it and snapshot them together in order. And the snapshot path, we're gonna set that to, let me see, what do we do here? Snapshot path, create snapshot path. Oh, okay. So Rust has, the cargo has this environmental variable doing build that is the out directory for any output that you have to write to disk for various things. So we're going to read that output directory and then concatenate it with, let's say, since we call this run.js, let's call it run.js snapshot. And just .bin to make it clear that it's a binary file and then that we're not going to be reading directly. That's going to be a snapshot path. And we will just pass that to the options. And that would be pretty much it actually already. I mean, we don't need to load this JavaScript file here anymore because it's already snapshotted. So we just have this extension with just the clear ops. And to make it more clear and not have conflicting names, we will call this run.js ops and run.js JS. Terrible naming, but it will do. Okay, so the main thing now is that we have to pass the snapshot that we got and that we are creating in the build script, and we have to get it while executing. So here we have a startup snapshot option, which we're gonna set to, oh god, let me quickly, snapshot. Runtime snapshot. Here we go. That was loud.
Wow, I can't believe you heard that. That was like from outside my apartment.
Okay, that was really loud.
Yeah.
So yeah, we're gonna statically include bytes from that snapshot with this. I mean, let me quickly just. Yeah, so we're gonna read the out directory during the build time. So this env macro just reads an environmental variable which is set during the build time, not during execution time. And we're gonna concatenate that with the directory for our, or rather the file for our snapshot, which we set to run.rs/snapshot.bin. So let's do that. And then we have this runtime snapshot static, which is just a slice of bytes, which we're gonna be passing them to the startup snapshot, so it can then load that snapshot and use it. We are including these bytes into the binary directly, because if we want to ship our binary to someone else, they're not gonna have that run.rs snapshot file on the system. So it needs to be built into the binary. So we are gonna get this snapshot enum, which gives us 3 different options. And we're gonna go with the static because we have a static slice. And just we're gonna pass runtime snapshot to it. And I actually believe that would be it. Let's I mean,
Wow.
famous last words.
Yeah.
Let's try if it works.
Especially in a live demo, it's very brave of you to say that.
Yeah. Assume this just takes usage.js file. Okay, so, and this is the example file. So example.ts. I guess we have not gotten any questions as of yet.
Not yet. Let me check this for you real quick.
Yeah, it doesn't seem like there's anything yet.
Looks like
All right.
that worked.
Yep, it worked. That was fairly straightforward, I guess. Yeah, we have spent various time to abstracting it as much as possible to make it as painless as we could possibly do. So
interesting. So now, so basically, you moved some of that logic into build.rs, and
yes.
does that mean that you have to like run build.rs before the snapshot is made, or like what is the order of operations with that?
For building, nothing changes. You still just do a cargo build. Because everything is taken off care of by itself. Basically, cargo is gonna run the build script before, like doing compile time. It's gonna execute it instead of just compiling it, like it would do for the rest. So it compiles it and executes it and does whatever we tell it to do, and then yeah, that's pretty much it.
Got it. And then when you execute it, it just loads the snapshot from build.rs and runs it.
Yeah, so the build.rs script creates the snapshots and writes it to disk somewhere that's definable, like that the runtime can then take. Like, we need a predictable place for it to be written to, so we know that's always there, and the system can reliably reach the file. And yeah, and we include this snapshot that we created into the binary itself. So if actually I open up the executable, we can then see that there is the runtime.js file inside embedded into it.
Got it. Very cool. So yeah, So basically, we have an example in we have an example of us reading the snapshot.bin. And then basically anyone, the snapshot basically is like an executable that anyone can read and execute. Is that right? Like in any environment?
Okay, let me go into a bit of a depth, and it is that the reason Deno cannot be cross-compiled is because snapshots are not cross-compilable. So if you want to use snapshots, you have to be careful that if you have a system set up that does cross-compiling, you will have to change that to have a CI script or whatever your setup is to be on every system that you plan to build for, or have like some emulation setup or whatever that some people do. But so yeah, it will work on all systems, but it's not going to work across different systems. So if I build this snapshot here and it is stored somewhere on my system, and I pass that to someone else that is running on Windows, for example, and they try to compile Deno with that snapshot that I passed to them, it's not going to work.
I see. So basically you have to do a snapshot specific to each platform?
Yes.
Interesting. Okay. Yeah.
I have a question.
Will Deno plugins make a comeback?
I mean, I'd like to say yes, but the reality is probably no.
For the viewers who don't know what Deno plugins are, do you want to give a quick
Yeah, so Deno plugins were a feature way before we had FFI support, and basically these plugins were a bit the equivalent of like, I think, Node API or an API, and they would basically let you create like op crates, which now we know as extensions, and you would just define an extension and compile that as a dynamic library that you would then be able to load into the CLI with some open plugin API. But there were many complications with that and some limitations on the side of Rust. So we pretty much dropped the existence of them, and FFI is just the way to go.
Got it.
I know it's rather limited in comparison, but and there's various features that were great of the plugin system, especially since with our ops, we have this op state, which is like the state of all the ops and being able to store things in the resource table and things like that. I'm not sure if there is example of using those here. No. But basically, you would have then be able a place to store globally information, and plugins would be able to use that. But that is exactly the reason why plugins got killed off, because it wasn't possible to do that in a proper manner across like dynamic libraries and stuff like that. It's been a really long time, so I don't remember all the details, but it was along those lines that it was just unfeasible to have that kind of setup. So FFI is the way to go. Plugins, I'm not going to say they're not going to happen, but they're not going to happen.
Thanks for your question, Bob. And if you want, I'm just curious, like, what specifically are you trying to do with Deno plugins /FFI? Like, yeah, let us know what you're trying to do, and maybe we can give you some better guidance around what we recommend. We have another comment from Azuri. Leo looks so tiny on that webcam.
Yeah, because I was leaning back with my chair, even though it doesn't look right. But yeah, that's.
Yeah, it's funny because I've video chatted with Leo several months before meeting him in person, and let me tell you, Leo's actually a very, very tall guy.
Yeah, the webcam pointing from above does cause some confusion.
Yeah, Leo's like I think one of the tallest people on our team, maybe, right?
I'm not sure if I'm still the tallest one with
Oh, that's
the
true.
new arrivals.
We just added new people.
But
Yeah.
I mean, maybe I still am. I mean, like at the last meeting, I still definitely was the tallest one.
Yeah.
So maybe
we'll find out in June.
yeah.
Okay, cool. Yeah, is there any other? I guess we still have time. Whoops, I just put our own thing here.
Well, if we still have time.
Yeah, we still have some time. Anything else you want to demo?
No, but we can answer. Oh wait, we have still the questions from
Oh,
chat.
that's right.
Wait, we got some questions from Bob. Understandable. I'm writing the generic. You're working in the Jupyter kernel. Something like so I thought it would be awesome to implement it for Deno. Yeah, I mean there was at the time a PR for implementing a Jupyter kernel into Deno. No, that's Deno Jupyter subcommand that would just include the Jupyter kernel in the CLI itself, but there were some problems with it, and it hasn't been worked on since. Maybe it will make a comeback. I mean, it's a useful tool. Do you know what Jupyter is, Andy?
Yeah, it's the writing Python, and it's like a REPL in Python for data science, right?
Yeah, and like VS Code has like integration for it as well, so you can maybe just make data science with Deno and stuff like that. That would be really cool.
I mean, that's a really cool application. Any idea why this PR was never merged in?
One of the dependencies was issue. I believe that like the protocol that Jupyter uses for communication, there's a dependency for that, but it was unreliable or something was missing, something along those lines.
Got it. Yeah. Any like, do you think that this is something that we'd revisit in the future? I know we got a lot on our plate in the coming months, so.
Possibly. I mean, I don't see why not. I definitely would say it's not a priority, but maybe one day, if there is a proper crate for that communication protocol that we need, then then it's probably even better. It's going to be fairly trivial. I mean, trivial, famous last words,
right.
But
trivial.
Yeah, but I mean, most of the logic is done. Like it's pretty much. I mean, Bartek did an amazing job. I mean, you can see that's 3,000 lines added, 4,000 nearly actually. So a lot of work was put into this. So yeah.
We have a question from Azuri. Are there any more news on when Deno will hit 2.0 or the next minor?
The next minor will happen soonish in the next. I
think it's in the next. I think it might be next week actually.
Yeah, it was said to be next week, but I think plan for that actually changed.
Oh yeah.
Yeah, it did. Expect it in the next few days.
Okay. Yeah, I mean, Deno 2.0, you know, we have very ambitious goals with it, and it's something that we want to make sure that everything is, all the I's are dotted and T's are crossed. So we don't have like a firm timeline for that, but definitely in the next few months. We got some pretty exciting things happening for that, and when it's ready, don't worry, everyone will know. Everyone will know because it'll be a big deal. That's all I'll say on that. Cool.
Yeah.
Yeah, why don't we just go over the questions
Yeah,
from the GitHub issue? Let's talk about that.
Let's quickly just cover these issues, these comments rather. So let's say your custom runtime is following the architecture of Deno, where we have a runtime crate drawing together Deno core, other Deno extension, our custom extension, and a CLI crate that builds on top of runtime and provides a CLI binary that can arbitrary JavaScript files in our custom runtime. Question: where should we create the snapshots? In runtime, CLI, or both? If we create a snapshot while building runtime, how can CLI create initialize runtime from the snapshot? If we should create snapshot both runtime and CLI, can the CLI snapshot be built on top of the snapshot by runtime? Okay, so to quickly answer the last question, as I covered that earlier, in that create snapshots API, you can pass a startup snapshot, aka a previous snapshot. That would let you build the CLI snapshot from that runtime snapshot. If we create a snapshot while building runtime, how can the CLI initialize runtime from the snapshot? What we have as a setup basically in the CLI is in the runtime crate, we have this js.rs file, which basically just includes and exports this runtime snapshot. And then you just use that, as I explained earlier. Let's say, where should we create the snapshots? So, I mean, where you create the snapshots is up to you. You don't need to create them both. I mean, we have that set up because we have all the people using the runtime crate as well. So in our case, if you don't have a multi-crate setup that both crates are exposed, but only the latter, like only the CLI one, you can also just snapshot in the CLI. That would also be possible, as long as you somehow manage to get the extensions over. I mean, that's just defining extensions in the runtime crate and then exporting them.
Great.
Then second question, I noticed that there's JS99 main file gets special treatment, different from other Deno runtime JavaScript files like 90 Deno.rs and 98 global score. Why is that needed? So the reason for that is that we want this 99 main to always be called as the last JavaScript file, because this 99 main file is basically the final build step, let's put it like that. It takes all the extensions that we have. It does some additional setup. It does defining like events, like the global error event or closed event, and defining the Deno namespace, like the final Deno namespace, some additional things like the TypeScript version or Deno version that you can get via the Deno.build API, the location API, and various things. So it's basically just a final build step. And we want that to be always executed last, because with our setup of snapshot from snapshot, we have this 98 global scope defined in the Deno runtime crate. However, we want to add more things to the global scope. Or in our case of the CLI, we have this 90 DNS, which is the Deno namespace, but we have the bench and testing functions defined in the CLI. So we had to figure out a way how we can define those additional functions in the CLI. And what we ended up having is we export this Deno.ns function from this 90 Deno NS file, and then in the CLI, you can just wait. Let me quickly find it. CLI JS in the testing file for testing. What we have done at the end is we input that file and that object that is the Deno namespace, and we just define additional functions to it. So we want the 99 main.js to be always the last function called, because it's basically it's the final function. It's what does all the glue logic, let's put it like that, together. So you always have to call 99 main.js as the last file. What is the recommended snapshot configuration? The struct does not have any documentation, but how do we use snapshot path and start of snapshot? Okay, those were covered by the previous questions. And number 4, when using snapshotting, when building the vec of extensions to the Deno core.js runtime, we call init ops and ESM during the build step and init ops at runtime. Is that correct? I think so. I believe that is correct. I will have to double check that. So yeah, I think that covers all the questions that were asked there.
Great.
And I guess we got a bunch more questions in the chat.
Yeah, we have this no Deno bundle in Deno 2.0. So basically deprecating Deno bundle. What do you know about that, Leo?
I mean, Deno bundle, it's being deprecated for a good reason. That is that we use the SWC crate for bundling, because they have some bundling capabilities. However, that is not maintained in any way, the bundling aspect of it. So that is the main reason why it's going, as it has been explained a few times. And there is no proper alternative as of now. I mean, I will always say use ESBuild. ESBuild is a valid resource. You say that ESBuild Deno loader is pretty much not actively maintained. Are there any missing features that you're looking for exactly?
That's a good question.
Because the Deno loader for ESBuild is being actively used, that's for sure. Fresh purely works based on of that. Without it, it wouldn't work. Just look at the repo.
Yeah, that's a good point.
ESBuild Deno loader. I mean, there was a commit 2 weeks ago. Sure, it's update dependency. It's not the most exciting commit, but it's not forgotten. There's been a fix 2 weeks ago. Sure, there's a few pull requests and a few issues, especially the doesn't work with node specifiers. But all of the node and npm specifiers, it's a non-trivial amount of work that at some point will be addressed for sure, as it is important. I mean, it would be great if Fresh would just then work with npm specifiers instead of having to rely on esm.sh. But
yeah, I mean, I think the project definitely is, it definitely needs a little bit more love. But Azuri, if there's any feature or something that you're trying to accomplish with ESBuild Deno loader that currently it can't support, definitely open an issue and we'll take a look at it.
Yeah. Also regarding implements, it definitely does work because Fresh does it. We do it. Like if I go to the .land repo, we have islands, and islands are definitely what are gonna get are gonna be bundled with the loader, and we can see there is definitely some non-proper imports that are defined in the import map. So pretty sure there is external import map number 1. Not sure what you're trying to say, but import maps in general support definitely available.
Okay, cool. We're coming up to the top of the hour, and thank you everyone for tuning in and checking out the live stream. if there's anything that you want us to cover for a future live stream, let us know either in the comments or on Discord. We're always there looking at stuff. And yeah, any final thoughts, Leo?
I mean, it's been nice to have been here.
Yeah. Thanks for joining us, Leo. Always a pleasure to have you. And yeah, just come hang on Discord if you have any questions. And I guess that'll be it.
Yeah.
All right. Well, have a good one.
See ya.
Talk to you soon. Bye.